Hello out there, guys. I hope you're ready today to work with me. We'll be focusing on representing of data, okay? And remember, when you do your mathematics, you need a pen and paper. It's not about observing. You need pen and paper, your calculator with you to try some of the problems, okay? And to think about some of the questions we'll be asking you. My name is Rakabu. I hope you're ready. This is going to be one of the good lessons. Okay, let's look at what we have today under representing of data. So under representing of data, before we do that, I have some few questions for you to answer. Let's look at the first question. How can an investor reduce risk on investment? Okay, so you have a lump sum of money, or it's an investment company, and you want to reduce risk. When I talk about the risk, is that you don't want to lose your money. Okay, so how do you protect that money? Okay, so usually investment companies, they take money, invest, or they buy stocks. So you want to study those companies. And to study those companies, you need data. How's their performance? How is the past 5 years return in terms of profit? Something like that. So we really need data also in investment if you want to invest and check, and we can able to calculate risk. And later we'll actually able to quantify what is this risk using a variable. Okay. What about the second question? Which is, how does a bank calculate your interest rate on a loan when one borrows money? Have you ever thought about that? How does a bank calculate the interest rate? You want to buy a car, and the cost of a car is 200,000 or something. You don't have 200,000 with you. You want to borrow the 200,000. So surely an interest rate, the bank will give you interest rate. How does it calculate that? Usually, you have companies that study individual. They collect data about you. When you default on a payment, I mean you miss a payment, they keep that. Okay, and so on. Then when you go to a bank, they check the data. They say, oh, person A, you had a loan there, a loan there, a loan there. You're paying all of them. But also they can check based on the data whether you can afford, okay? And surely if the probability or the chance that you might miss a payment are very high, they'll give you a higher interest rate. So data can be used in different ways. From a loan, individual person, or just calculating a risk also. Okay, fantastic. Hope this makes sense. Now, let's look at more questions to think about. Does lockdown reduce the COVID-19 from spreading? Okay. What is a lockdown? By hard lockdown, no movement, you have to be at home unless you go and buy essential service. And lockdown get eased also, but do you think, personally, does lockdown reduce? Based on data we've been observing, yes. After lockdown has been eased, relaxed, we're allowed to walk, we can go for a run, we can go to a park, then numbers of infection started increasing based on the data we observed that, yes, a lockdown can actually decrease the COVID-19 infection. Okay. I hope you thought about this by now, and it's a nice question to think about it. Let's look at another one. So, also related to the COVID-19, how long will the second wave of COVID-19 last in South Africa? Any view? So when I talk about the second wave, I mean the first wave, it's when the COVID-19 started. We had like a hard lockdown, then lockdown was eased, and I think the maximum infection daily report was approximately 13,000. So we had something of this nature when we started. So we had a maximum, then it started decreasing based on data. So here was the maximum amount of infection, then it started decreasing, so on, because of the lockdown there, okay, because of the lockdown. Then now, will we have a second wave? Second wave will be this second part, because now we're decreasing, is going up. Will this part be higher than this or lower than that? Okay. In simple terms, will the second wave, will we have more than 13,000 cases reported now? Because in the first wave, the maximum was about 13,000. Can we record something like that? I think we're getting close to that. But to answer that question, we don't have data. We can try to predict, and we might be wrong, but we can wait for the data and see what is happening. But one can sense from the current data that we're actually approaching that the second wave might be close to the first wave or even higher than the first wave. Good, interesting question of what is affecting us. Lastly, how can we tell if the second wave is higher than the first? Okay. I mean, the first wave, we know the maximum infection was around 13,000. We will tell if in the second wave we can record around more than 13,000 daily infection. Okay, that's how we can tell if we'll have, if the second wave is higher than the first wave of the COVID-19. Okay, interesting question. So data is used on daily basis. It can be in reporting of the pandemic, can be used by the bank, can be used by the investment firm. Anywhere, data, it's around us. And this is the world of data and statistics. It doesn't matter. Data is not for engineers, for scientists, for biological science. Even as psychologists, you need understanding of data. I mean, now we're actually in the fourth industrial revolution. And the fourth industrial revolution is about the collaboration of human, us, and machines, okay? And that, most organizations that understand data will able to make lots of profit. So this is the world of data. So it doesn't matter what kind of career, sports scientist, anything, one need a little bit of understanding in the fourth industrial revolution. Fantastic. Let's see what we have now. So what are we going to look? We'll look at, this is some of the stuff we'll look, line graph, bar graph. This is how you can represent data, pie chart. We'll look at some of them. Pie chart, box and whisker, we'll discuss that. This is just the box which contains the minimum value, the maximum, the middle, and the lower and the upper quartile. We'll also look at the scatter plot, histogram, and frequency table, frequency polygon, and cumulative frequency. Okay. So let's look at some of the keywords, which is cumulative frequency and frequency. Cumulate, what does cumulate mean? Cumulate, if I have 10 Rand, tomorrow I have 20 Rand, then I add, I have 30. I keep on adding, but I'm accumulating that. Does that make sense? Even if you look at how the COVID-19 is reported, you add daily cases from the current, from the total. So you keep on accumulating. Okay, does that make sense? Okay. Then frequencies. Frequency is the total tally, okay? So if I make an example, I'm going to make an example using the pandemic. Let's say people who are affected by the pandemic between the age of 19 to 30, if the total is 100,000, then the frequency is 100,000 in that interval. Does that make sense? Okay. So we're going to look at another way, which is frequency table and tallies. So frequency table, okay. Remember, in data, we can have grouped data or raw data. Group data, we can group data. For example, if you go back also, which is interesting, the COVID cases, some of them are grouped according to age in terms of infection. So that is a frequency table. We have kids between the age of 0 to 9, how many actually died from the COVID-19? You have a number. Between the age of 9 to the age of 20, how many? Between the age of 20 to 30, how many? How many that? It's frequency. And that is the frequency table, okay? Because you have an interval and how many in that specific. Does that make sense? Okay. Then the tally is actually the total in that interval. Interval meaning, let's say, between the age of 0 to 1, how many people died with COVID-19? We count them. Those are the tallies, which give us the frequency. Are we all together? Okay, fantastic. So it's a frequency and tally. Now, we're going to look at more keywords, which is discrete data and continuous data. Discrete data, it's like specific, like 1, 2, 3, 4, 5. That's discrete data. If I have a dice, I roll a die. I can get 1, 2, 3, 4, 5, 6, which is discrete data. It takes a specific value. But what about continuous? Continuous data can take any value, something like temperature. Today, it could be 31.5 degrees Celsius. Tomorrow, it could be 31.5 degrees Celsius. So it takes any data set. So we're discrete, a specific value. Okay, fantastic. That's the difference between discrete and continuous. I'll be using that kind of terminology as we continue. So we will look again. If you go back, this is what we will focus on: the bar graph, line graph, and the Whisker plot. Scatter chart, cumulative frequency, frequency polygon. This will be defined later. All the bar graphs, some you might be familiar with, and the Whisker plot. Okay. So what are we going to do now? When we come back, we're going to take a break now. And after the break, we'll come back and look at the bar graph and the histogram, okay? So let's take a short break. And I want you out there to think about, how does the bar graph and histogram look like, okay? So sit there, think about it, and after the break, we'll go through the two representation of data. Welcome back once again, guys, okay? So remember also, mathematics is about consistency, and I'll speak consistency continuously to you, that you don't just work on the day you write a test or something. It's something that you do it on a daily basis. even though you're not writing an assessment. Okay, on a daily basis you work. So it's better to do 20 minutes per day, 30 minutes per day, than doing 5 hours because you have a test coming. So you can be continuous now, consistent now. That will make a huge difference in future. It's not about how many hours you're going to add per daily basis. It's the consistency. And I'll really encourage you to be consistent in your mathematics. Okay. Now, let's look at again. We said when we come back, we'll look at the bar graph and the histogram. So comparing bar graph and histogram, a bar chart are frequency diagrams that are categories along the horizontal axis. Does that make sense? So bar graph are frequency diagrams that show categories along the axis. What does it mean? It could be colors, yellow, white, black, male, female, okay, something like that. Okay, so on the x-axis, on the horizontal, you'll have your categories, okay? It could be gender, it could be race also, something of that nature. There are gaps between the categories. So you have a block like that, another block, but there are gaps between those categories, okay, for the bar charts. Are we all together? Make sense? Okay, so gaps, you have gaps there, something like this. Frequency is, so if you look at this, we have a bar graph showing learners travel to school. So this implies learners can walk, take a bus, bike, or car. Frequency will be how many learners walk to school. How many? You count them. So that will be the frequency. Bars, and you can see, what we see here is that bars is actually the mode. Mode implies the most occurring. Most of the learners at the school, they use bars to get to school. So those are the categories, because we're talking about traveling to school. It either can be walk, bus, bike, or car. And the frequency is actually the actual numbers. And if we look at this, we can see, I mean, we don't have the actual number here. I mean, we can see that that is the highest point, which is the bus, and followed by the bike, okay? Then after that, followed by a walk, and we have about, lastly, about few lower numbers actually use a car to get to school. So this is the bar graph. You can see there are gaps between, there are gaps there. Are we all together? The blocks don't touch each other. Are we all together? Fantastic. Okay? You need to know how to draw this and how to interpret this. Now, let's look what we have here. So this is the bar graph, and those are the bar, and those are the categories. Okay? Categories, you can have anything there. Comparing bar graph and histogram. Histograms are different to bar graphs. Yes, we do agree. Histograms are frequency diagram that shows grouped data values along the horizontal. Interesting. So the histogram shows grouped data. What do I mean when I say grouped data? Group data can be how many people between the age. Even if you look at how our minister reports on the COVID-19, the data is grouped in how many people died from the COVID-19 based on age. They'll say 70 to 80, how many people? 40 to 50, that's grouped data. So histogram, we use it to represent grouped data. Are we all together? Where a bar is just categories. Now, there are no gaps between the categories. There are no gaps. There are no gaps, but we spoke about grouped data, and there are no gaps. So the blocks can touch one another. Okay, are we all together? There are no gaps. Let's see, what do I mean? Example of histogram. There it is. So let's say meals sold during the week at the school or somewhere else. So frequency will be the meals sold on Monday. That will be the number there. I think if this is, let's say this is 5. Let's say the blocks get going 5. This will be 10, 15, 20, 25, and so on. So we can see that on Monday, 25 meals were sold. What do we see? The blocks, they touch. Are we all together? Are we together? But here, we don't even have, this is not even, we group Monday, Tuesday, Wednesday, Thursday, Saturday, and so on. Okay. So, no gaps between bars, you can see that. That's very important. Numbers of different pads owned. Let's look at this. There's a frequency. Each category is given a category. Okay? We can see that. So the number category placed directly underneath the middle bar. Okay. So the comparing of bar and histogram. Histogram can be used to show both discrete and continuous data. Remember that discrete is like specific, that value, where continuous can take any value like temperature, and discrete is like a flip of a die, which I can get 1, 2, 3, where continuous can be like a temperature, something like that. Okay. So histogram can be used to show both discrete and continuous. So let's look at that. So those are the COVID-19 positive case, arranged according to age. So this is discrete data, and this is continuous data, which is temperature. Are we together? So, I mean, if you look at this, between the age of 0 and 9, there's nothing. Between the highest age, the modals class, we're going to call that a modal. I'm just going to talk. If you look at the age between 30 and 39, is the highest frequency. So that age has the most positive COVID cases, okay, reported. If you look at the data, I'm not sure how long that data is worth, for a month, for a week, or so on, okay? Are we all together? And if you look at 50 to 59 is the lowest in this chart. Maximum daytime temperature, okay? So this is what we have. You can see this is continuous and discrete, which can be done by the same. We can look at runs scored by an opening batsman in one-day cricket. So this is grouped data. Remember, when you play cricket, you get runs, which are the scores, okay? So the opening batsman is the first person who will bat at a cricket match. So about 5 runs, between 0 to 19 runs, we have 5 batsmen. Can you see that? We've got between 0 and 19 runs, between 20 and 39 runs, which is the score. It's about 9 there, we can see. And actually the mode, which is modal class, is the modal class. Why do we call this a modal class? It is between 40 and 59. Because we don't know the actual mode in grouped data. So we can only tell the highest frequency, which is the modal class. Are you all together, guys? Okay. Great. Hope so. So let's look at this. So what we can do, if you look at this, we have 16 runs there, which is about that, followed by 9, then followed by 5 runs. And if we add all this, I think we get 30 runs. Okay, are we together? This will be runs smaller than 60, which are actually 30. Okay. So we're back. What we've discussed is a bar graph and histogram. Okay? Are we all together? One with the gaps, one without gaps. Okay? Categories and grouped data. Okay. So we looked at bar graph and histogram. So now let's see. We're going to look at frequency table. What are frequency table? Frequency table is used to organize raw data into class interval. Raw data, so frequency tables is used to organize raw data into class interval. So if I go out there and test how many people with COVID-19, we get, okay, we have 100,000. That's raw data. We just have 100,000 with COVID positive. But now when we start grouping according to age, and say between the age of that and that is grouped data in frequency table, because we're putting the age groups and how many in each age group. And how many in each age group, that will be the frequency. And the interval, meaning from the 0 to 9, 9 to 20, that will be the interval. We're grouping that in intervals. Okay. So we're grouping raw data into class intervals. So class intervals will be like age, the category, between the age of 9, 10, and so on. Let's look at this. So these are the runs from a cricket game. Okay, so these are the scores. We can see, I mean, this was 42, 34, 39, 49, we can see, and so on. Okay, this is raw data. It's just random there. Okay, now, if I want to represent this data into a frequency table, I need groups. So how are we grouping this? The runs between 0 and 19, runs between 20 and 39, 40, 59, 60, 79, 80, 99, 100. Then I have to tally. I have to count how many runs between 0 to 19 from the raw data, from this raw data. Are we all together? So if you look at this, between 0 and 19, we have 4. So this lines, this means if I have 1, this means 1, that means 2, that means 3, that means 4. If I put a line like that, that means 5. Are we all together? How will we represent 10 in tallies? It will be 1, 2, 3, 4, 5, because this is 5 and 5. Are we all together? That makes sense. Okay, so we represent 1 with a line, 2 with another line, 3 with another line, and 4 then 5, we just cross it, that means 5. Are we all together? So, between 0 and 19 we have 4. there. Let's see actually which is 4. Be 0 because there is 1. 0 falls in the interval 0 to 19. Can I find another one from the raw data, which is this, 18? That's the second one. Where is another one? Can be, can I see another one? 5. Oh, I see 5 there, which is the third one. I need the fourth one. Should be somewhere here. There we see. Where is the fourth one? Okay, 12, which is the fourth one. Are we all together? Then, the frequency will be the total tally. I just have to check. This is 4 in there, 4. So there's runs between 0 and 19, there are 4. Runs between 20 and 39, there are 13. Because it implies, this, remember this is 5, and this is 5, and this is 3. Because it's, how many lines? It's 1, 2, 3, 4, a line, that means 5. Another one, 1, 2, 3, 4, a line. It's 10 plus 3 lines, which is 13, which we get in. Then 40 to 59, which is 9, and 60 to 79, which is 7, and we have 5 there, and we have 2. So what we have done here, we took a raw data, which is data there, 40, 10, 0, written down. We put that in a group. I mean, this is better. I want to know how many of actually the players get between 0 and 19 runs. We can see there's 4 of them. And here, let's look at the model class. The model class will be the most occurring, which is the highest frequency, which is which one? 20 and 39 is the one with the highest frequency. Can you see that? So which is 20 to 39 is the one with the highest frequency. So if you look at this, we had our tallies there, and we had our frequency. Okay. So we looked at the bar graph, we looked at the frequency table, we looked at histogram. Now we're going to look at the frequency polygon. Okay. So, which is another way of representing data. So I think after now, what I'd like you to think is, what is this frequency polygon? You know what is frequency mean? Do you know what is a polygon? How does a frequency polygon look like? Then after the break, we'll unpack the frequency polygon. Okay, see you soon. Welcome back again, guys. I hope during the break time you thought, what is this frequency polygon? What does it look like? Have you? I hope so. That's very important to think sometimes. And it's okay not to know the answer, but it's good to think. Okay. So let's look at the frequency polygon. A frequency polygon is drawn from frequency table. We know what is frequency table. Okay, which is class and frequency. Frequency, which we get them from tallies, from counting. We're going to find the midpoint of each class interval. And remember that the class interval is when we group raw data, we group raw data into class interval. That's what we're going to do. Let's look at an example. Marks for a class test on statistics out of 30. So these are the marks, okay? We group them, so students who wrote a test, and they got marks out of 30. Are we together? We can see there's someone who got total 30 out of 30. How many learners got between 5 and 9? Not 7. 4 learners. I'm making a mistake. Why 4 learners? We're counting the frequency. The frequency is how many in the interval. How many learners got between 10 and 14? 10 learners, and so on and so on. Does that make sense? How many learners got between 25 and 30? 8 learners. So to draw the frequency polygon, we have to find the midpoint of the class interval. So the midpoint for 5 plus 9 divided by 2, that gave us 7. That's how we found the midpoint. So we add the boundaries. That number plus that number divided by 2. That's what we do, okay, to find halfway of the class interval. The midpoint, which is the halfway of this, is 10 plus 14 divided by 2, which gives us 12. Similarly, 15 plus 9 divided by 2, 17, and 20 plus 24 divided by 2, which is 22, and so on. Now, we have our midpoint and we have our frequency. So what are we going to do? We have to draw the midpoint and the frequency. Treat that as a coordinate. Do you remember what is a coordinate? The x-axis and the y-axis. We start with the x and then followed by the y. Okay, so this is how it looks. So there's the midpoint for that, interval, midpoint, interval, midpoint, interval, then midpoint, interval, midpoint. Now, a frequency polygon is drawn from frequency table. We agreed. We find the midpoint for each class interval. We did that. Plot the midpoint on the grid. That's what we're going to do now. The midpoint, we're going to plot the midpoint. These are the midpoints on the grid, which is 7, 12, 17, 22, 27.5. Those are the midpoint. We're going to draw them on our grid. Plot the midpoints on the grid. Extend the line to the midpoint of half the class interval before the first interval and after the last class interval. Then after doing that, we're just extending our line, half interval, both ways, at the start and at the end. Let's see how it looks like. This is our grid. So the midpoint for 5 and there, what do you call it? It was, no, we got frequency. Let's check there, 5 and 7. What do we had? 5 and 9. I mean 5 and 9. 5 and 9, the midpoint is 7, and the frequency is 4. Okay, there we are. We get 12 there, get 7, 12. For 15 and 19, we get 17. And 20 to 24, we get 22. And lastly, 25 to 30, we get 27.5. Then we connect with a ruler. Okay, that's what we get. So a frequency polygon. A frequency polygon is drawn from a frequency table. What we did, we found the midpoint for each class interval. Plot the midpoint on the grid. That's what we did. Extend the line to the midpoint of half the class interval before the first class interval and after the last class interval. Then draw in the bars. Okay, that's the frequency polygon. Are we all together? Can you see that? We're together. So those are the interval. Are we all together? We find, in an easy way, you find the midpoint for each bar, halfway for each bar, midpoint for each bar, midpoint for each bar, midpoint for each bar. Then you connect those midpoint with a ruler. Then remember, you have to go half the class interval this way and half the class interval this way. Are we together? So you have those bar, midpoint, midpoint, which are there, midpoint, 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 half interval, half there, connect with a ruler in simple terms. Are we together? Let's look at the Whisker plot, what it looks like. So the Whisker plot is a box which contains the 5-number summary, the minimum value, lower quartile, median, upper quartile, and the maximum value. This is how the Whisker plot looks like, which is the minimum value there, Q1, which is the lower quartile, Q2, which is the median, and Q3, which is the upper quartile, and the highest value, which is the maximum. Box and Whisker plot shows both measure of central tendency and dispersion. Okay, that's very important to know that. But what is important about, let's look at the data. The Whisker plot can be used to compare two sets of data. Let's look at this. So we have numbers there. This is how we can see that the middle one is the median. Then from the middle from there to there, we can find another middle, which is Q1, which is the lower quartile, which is 4. Then the middle of that last 50% of the data, we find Q3, which is 10, the upper quartile. Then we draw the Whisker plot, which is our Q1, median, upper quartile, highest value, and the lowest value, thus the Whisker plot using the 5-number summary. So box and Whisker plot shows both measure of central tendency and dispersion. I did indicate useful for comparing two sets of data. Now we want to look at cumulative frequency, very important. Cumulative frequency graph is also called an ogive curve. So cumulative frequency used to obtain an estimate of median quartiles from set of group data. So we'll start by drawing the cumulative frequency table. Cumulative frequency just means running total. You have 10, you get 2, you add, you get 12, you get 2, again you add, you get 14. It's just a running total. That's the cumulative frequency all together. Very important. So let's look at the frequency table with an example. During a 4-hour period at OR Tambo Airport, number of late arrival aircraft were recorded. So this is an interval, numbers of aircraft arriving late. So you have about 5 aircraft arriving 10 minutes late by 10 minutes, between 0 to 10 minutes. You have about 8 aircraft arriving late by 10 to 20 minutes, and so on. So these are the frequencies we know. We will use the upper limits also. What is the upper limit? This will be the highest in each interval. The highest is 10, the highest there is 20. Now we're going to do the cumulative frequency. The cumulative frequency is the running total. Let's do that. So it will be 5, which is that, 5 plus 8, which is 13, 13 plus 22, and so on. This is a running total, which we get 60. So we just accumulate, keep on adding, we get 60. Now, to plot, we're going to plot the end point of each interval against the cumulative frequency for each interval. Then join points to make a curve. Let's see. So what we have now is the points, the cumulative frequency for 10, the end point is 10, and the cumulative frequency. So the end point, 10, another end point was 20, 30, 40, 50, 60, 70. Then we plot them, and we connect with a ruler, and we get our cumulative frequency. So how do we get that? We join the end point of an interval using the cumulative frequency. You're making that an x-axis. We can use the cumulative frequency to get the quartiles. Let's see how. So we can estimate the median. We can also, how? Let's see that. From 0 to 60, what is the midpoint? It's 60. So using your ruler, you go there, then you read down that value up close to 30. Can you see what you're reading there? Is about 27. So that's the median. So how do I get that half? I know half of 60 because there's my cumulative frequencies from there to there. Half will be 30. Then the lower quartile, similar. We'll do the quarter of the cumulative frequency. Quarter, we're going to go and read down. What do we read? Something more than 20, which is 21. Similarly, upper quartile, we can do the same with the upper quartile. We go up 3/4, then we read, we get 38. We can use the cumulative frequency to calculate our quartiles. I hope this makes sense, guys, and we hope to see you soon, and keep working hard at home. Bye-bye, guys.